Hello, Mandela. How's everyone doing? I'm recording this on Sunday night here for our hub class this week, in what is a really weird week in the sense that we have some total of 3 school days this week. There is Teachers' Convention on Thursday and Friday. I will be sitting right here presenting for convention, as I do every year. Not virtually, per se, but in some way, shape, or form. And so you guys only have classes Monday through Wednesday this week, and that's going to change our schedule up a little bit. So without further ado, here's a quick overview of what you should be doing this week. If you're an introductory, we are going to have our meeting on Wednesday at 9:30 a.m. This is different than a normal week. Normally we do Thursday. This is a bit of a one-off. If you have a conflict with that, throw it in the discussion chat, and I'll mark you in the attendance as MS, modified schedule, and life will be good. But we should have a class to talk about these 2 assignments. If you have questions about them, obviously put them in the discussion forum. I know some of you have already gone and done that. Now, both of these assignments are things that you should have the skills for already. So a lot of the background skills behind these, I'm not going to be teaching, but if it comes out that we need them, we'll go from there. Because you have as intros to go through and actually finish up the measurement and unit conversion task. There's not that many things here. There's only, I think, 11 questions on this one, and most of it is about talking about the difference between the metric and imperial system. There's a couple really good videos on here about why we use metric, why we use imperial, how the switch happened between those two. This matters a lot in engineering. It's a big deal. Also, I want to make sure that you are confident with your metric prefixes. This table right here is very important in terms of you knowing the difference between, say, a mega ohm and a kilo ohm. Those are very different things when we start talking about electronics, and you should really know what those are. Inevitably, somebody has an LED in this class that doesn't turn on because instead of putting on a 1001 kilo ohm resistor, they've put a 1 mega ohm resistor on it and they didn't notice. Happens more often than we'd like to say. That being said, that's a really quick one. This should take you all of an hour at max, I would believe, and if it's taking you more than that and you're struggling, again, discussion post, ask me the questions that you need answered and we'll get back to you as quickly as I can. I want to say thank you to everybody who got their e-portfolio set up. If anybody did not at this point, you will see a message in your discussion post saying, hey, I can't see it yet. Probably means you mistyped something. If you need guidance on how to go through those, we can set up a meeting sometime. Life is good. The other thing you do need to do, if you're an intro here, is the Exploring Engineering project. Now this one is a relatively simple project. I'm expecting everybody's going to do these individually, but if you're going to work in a group, please drop it in the discussion forum as to who you're working with. I don't mind working groups of up to 3 on this one. If you already know people in the class, that is awesome. Basically, your task is to go ahead and actually do some research into the branches of engineering. In this case, we're going to take the main 5 branches: civil, mechanical, electrical, chemical, and interdisciplinary, and you're going to do a little bit of research. Each of these branches kind of has a main focus. So civil engineering looks predominantly at infrastructure, which is the pipes, the roads, the sidewalks, the buildings that make up our cities and our lives. Bridges are a big thing in civil. Anyways, what I want you to do is do some research into all 5 of these. And I've given you the research topics. If you scroll down to the bottom of the page here, this is under 0.4, I believe, in the introductory course site. Down here, there's some great links talking about the branches of engineering, what engineering is, as well as some of the stuff we're going to use later in the assignment around Schulich School of Engineering here at the University of Calgary, SAIT's Engineering Technologist programs, as well as things like APEGA, the Association for Professional Engineers and Geoscientists of Alberta. Basically, your task for the first little bit is to actually go out and find the basic description of each of these 5 things, and then a sub-branch. 3 sub-branches for each of them. Those 3 sub-branches are going to go into here as kind of some things that you might do if you were in that area of engineering. Now, I'm going to give you an example of this because I have one from past years, and I'm just quickly going to show you that for this one, it used to be 1.1, different number, same assignment. This student's gone ahead and she actually said civil engineering, engineering discipline, skill in developing infrastructure. They talk about those things I just talked about on one slide. On another slide, she's broken it down into three different pieces of civil engineering. She's talked about forensic engineering, okay, looking at specifically structural forensics when buildings fall down, transportation engineering, looking at how people move around, and geotechnical engineering, how we deal with things in the ground. And she's given us a really quick overview of all 3 of these. This assignment isn't a hugely in-depth thing. For each of the disciplines, she's done the exact same thing, showed us a quick description of the major discipline, and then a bunch of sub-disciplines. Interdisciplinary is very cool, because a lot of the things that fit within medical, biology, things that are connected are really, really cool in here. Now, that being said, those two assignments, and I mean, most of you should have started work on the measurement unit conversion before this week. That's all good. Many of you may have that done already. I've seen a few discussion posts already. Nothing wrong with that. Okay. For the exploring engineering, I would expect you guys to be working on this throughout this week. Now, that's part one. There's 3 parts. Part 2 is that each student, if you're working in a group, you have to do this multiple times. Okay. You have to go out and find a specific kind of career in engineering and find a career. It might even be one of these subdisciplines that you've already talked about. Find a specific project that engineer or engineering technologist might have worked on. What work would they do on a daily to monthly basis? Because obviously if you're a computer engineer, software engineer, your life is going to look very different than if you're a structural engineer looking at bridges. Their annual salary, and we have links for that near the bottom, and post-secondary schools in Calgary that offer the program. This is probably going to be U of C and SAIT. They are our primary engineering schools within the city of Calgary. And I want you to post the entry requirements for getting into that program. Okay? This is going to be all put together in a Google Slides presentation. Life is good from there. And like I say, if you're working in groups, I'll give you some more guidance in your discussion forum from there. Lastly, I want you to take a look for task number 3 at an engineering school that's not in Calgary. You can go up the road, you can go to University of Alberta, that's fine to look at, or you can go far afield. This building here, I believe, is from MIT, Massachusetts Institute of Technology, widely considered to be one of the most innovative engineering schools in the world. I want you to look at that program and ask 2 things. 1, why would I want to go there? What's a good reason why I could go to that school? And 2, and for some it might be a specific program. I often get students asking specifically about, aerospace engineering, which you often have to go to Calgary for. I often get students asking about Waterloo and some of their computer engineering programs. As well, I want you to look at what it would take to actually get into that institution. Post that on your slide, reference it all properly, and by properly I mean post the URLs. I'm not requiring a formal referencing piece right now. That comes later in this course. But basically, I want you to show me that you understand both what engineering is and what it might take to get into one of those areas. That's your second project for today, and I know with Hub, time gets a little muddled, so you do have a bit of a long weekend to work on this over at the end of the week. But if you have questions about it, Wednesday morning at 9:30, I'll send out the link that morning. That's the time to go in, and that's where we're going to work from there. Okay, that's the intros. So intros, if you guys want to log off of this video here and stop watching now, you are more than welcome. If you're an intermediate and advanced, I'm going to talk about your stuff in just a second here. So let's shift over and let's talk intermediate advanced. So you guys, for the most part, I think everyone's set up their e-portfolio and has let me know that in their discussion forum. If you haven't done that, please do so as quickly as possible. Your task for this time around is actually the robot research project. I'm going to pull this up on the screen here. It is on the introductory course site, and the reason for that is that this is a credit that you're doing that kind of spans intro and intermediate. Some years I get enough time to go through this credit with the introductories. Some years I introduce it with the introductories, but we don't get to finish it. All sorts. Some of you might actually have an in-progress version of this project sitting in your e-portfolio from last year or the year before potentially. I guess just last year for intermediates. This one is something where you just have to go in and look at a robot and actually tell me a few things about its history. So you're going to put together as a document or a slides presentation. I do prefer slides presentations for this one, and throw it in your e-portfolio. Okay, you don't have to number this one, though I will recognize 1.10. Again, it is kind of a between introductory and intermediate credit. Often we do it as a bonus in one or the other of those courses. That being said, you're going to take a picture, take a look at one of these robots, and some of them are robots that you guys hear about a lot in the media, things like Boston Dynamics and their robot Spot, Atlas, Handle. These are really, really cool robots. Okay, you could look at things like Recon Robotics. This is a tactical robot that's often used with SWAT teams and military. They actually use it often in reconnaissance, sometimes bomb disposal even, when they have to throw a robot through a window and actually have the thing be... Let's put it this way, when we have something like this, you are much less likely to have loss of human life when dealing with something like this. Many reasons why we use robots. There's a few options here. If you have a robot that's not on this list that you actually want to do your research on, leave it in the discussion forum. I'm probably going to say yes, okay? Unless you say Wall-E, because that's not a real robot. That's an adorable robot, but not a real robot. This is something where I want to actually make sure you have something real so you can look at the company that made it, okay? Some of them are really weird too. Something like SpaceX's robotic rockets. I mean, SpaceX rocket is unmanned. It is an autonomous robot for all intents and purposes. It is fair game for this project. Your presentation has to cover the following things, plus anything else you find relevant for the topic. I often find weird and wacky things that don't fit the questions, but people want to tell me about these robots. And if that's there, please make a slide for it. I want to know what the history behind the company developing the robot is. I want to know what the history behind the robot itself is. I want to know if the robot is remote controlled, which is a term we use as teach pendant. It's a little bit of an outdated term, but still gets used occasionally. Or it's autonomous, or it's somewhere in between. Some robots actually exist in that gray area between, especially if you're talking like self-driving cars and autonomous vehicles. Right now, they're somewhere in between autonomy and being controlled. What role does the robot fill that humans can't? Basically, why does it exist? And why can't humans fill that role? Some of these are a little bit more obvious, some of them aren't. I mean, a SpaceX rocket, obviously, it's a vehicle that, if you've ever watched one of those things land its booster, when it actually comes down and self-lands itself, the amount of, I guess the calculations involved in landing that are far, far beyond a human. Whereas some of these things like Casimo, Honda's humanoid robot, it's meant more as a companionship robot in many ways. And so it's not that humans can't fill that role, it's that in Japan there's a lot more elderly people than there are young people, and that causes its own set of problems. Also, what features or subsystems make this robot unique? So what sets it apart? And I mean, there might be some overlap, by the way, between some of these questions. I mean, these last two questions might have the same answer. Lastly, I want you to tell me what energy systems exist in the robot. Is it battery powered, which would be electrochemical? Is it, pneumatic? Does it work off of solar, wind, hydraulic? And what happens in that robot in terms of conversion of energy? How does it go from an electrochemical battery, for example, to movement of, let's say, a robotic arm? That might be electromagnetic. I want you to walk me through what systems exist in the robot, because some of these robots are purely electrical robots. They purely work off of a battery, electrochemically stored energy that converts to electrical energy, that converts to electromagnetic energy, that converts to mechanical energy. Those are the pathways I want to hear about in the robot. And if you're not sure, throw it in the discussion forum. We can have a conversation about this. Presentations include imagery and video wherever possible. I don't mind if you embed some videos in here. That's awesome. Good job. Okay. Throw your first names on this. Make sure I know who it is. Make sure they get thrown in your e-portfolio, and all sources of information must be referenced. You must show me where you got your information from, because it definitely helps me in a lot of senses here. With that being said, that's our one thing for this week. Get this done. It's due after the long weekend. I'll start looking at them as they come in over the weekend. Again, a question came in on the discussion forum. Do we have to let you know when we finished everything? You don't have to. I mean, it's appreciated if you throw that in the discussion forum, but you don't have to. I'll start looking at them next week, and we can start updating some credits and getting on to the next piece, which will be our electronics and our CAD. That being said, I'm filling space at this point, so let's call this a video. You guys can get yourselves to work, and I'll see you in intermediate when we have our actual conversation on, I believe, Tuesday morning at 9:30. We'll send the Google Meet link out that morning for that, and maybe post something in the D2L shell as well, and we'll get talking from there. With that being said, guys, have yourselves a wonderful start to the week, and if you have any questions, they go in the discussion forum. Cheers.